As the moon's shadow danced across the European landscape, a rare and fleeting spectacle unfolded, a total solar eclipse. Yesterday, between 2026 and 2034 CEST, parts of the Iberian Peninsula were bathed in an otherworldly light as the moon passed directly between the Earth and the Sun. The event was so brief that it left many wondering if they had truly witnessed something extraordinary. But one satellite, MTG-I1, was watching with unblinking eyes, capturing the eclipse path of totality over Europe with crystal clarity. Its images reveal a stunning convergence of celestial mechanics, the moon's dark shadow merging with the advancing twilight shadow as dusk fell over the continent. The Meteosat Third Generation Imager satellite, or MTG-I1, has been orbiting Earth for some time now, keeping its imaging instruments trained on Europe and northern Africa from a distance of 36,000 kilometers above our planet's surface. This vantage point allows it to track the weather patterns, storms, and other atmospheric phenomena that shape our climate. But yesterday, MTG-I1 was tasked with something more extraordinary, capturing the path of totality as it swept across Europe. The concept of a total solar eclipse might seem simple enough. The moon passes between the Sun and Earth, blocking the face of the Sun for a short period. This alignment is no easy feat to achieve. The moon's orbit is tilted at an angle of about 5 degrees relative to Earth's orbit around the Sun, which means that their paths cross only rarely. In fact, a total solar eclipse occurs somewhere on our planet about once every 18 months, but most of these events are not visible from any given location. The path of totality is a relatively narrow region where the moon's shadow falls directly on Earth's surface. It's usually around 100 kilometers wide and stretches for thousands of kilometers across the globe. Yesterday, this path passed over Greenland and Iceland before making its way to Europe, where it brought a brief, but intense moment of darkness to parts of Spain. The MTG mission is not just about capturing spectacular events like solar eclipses. It's also focused on providing critical weather forecasting data for European countries. The Meteosat Third Generation satellites are designed to offer high-resolution images and detailed forecasts, helping meteorologists predict severe weather events and mitigate their impact on communities. As we continue to explore the complexities of our atmosphere and the celestial mechanics that govern Earth's place in the universe, projects like MTG-I1 serve as a reminder of humanity's ongoing quest for knowledge and understanding. The data collected by these satellites will not only help us better predict the weather, but also contribute to a deeper understanding of the intricate relationships between our planet and its surroundings. The next chapter in this story is already unfolding. Later this month, on August 27th, MTG-I2 is set to launch from Europe's spaceport in French Guiana aboard an Ariane 6 launcher. This new satellite will join its predecessor in orbit, further expanding the capabilities of the MTG mission and paving the way for even more precise weather forecasting and research into our planet's dynamic atmosphere. As we delve deeper into the details of MTG-I1's extraordinary capture of the eclipse path of totality over Europe, let's examine the satellite's technical specifications that made this feat possible. From its vantage point in geostationary orbit at an altitude of 36,000 kilometers above Earth's surface, MTG-I1 was able to track the moon's shadow with remarkable precision. The Meteosat Third Generation Imager satellite is equipped with a range of advanced imaging instruments, including the high-resolution visible (HRV) and infrared sounder (IRS) channels. These instruments are designed to capture high-resolution images of the Earth's surface and atmosphere, allowing meteorologists to track weather patterns and predict severe weather events. In this case, MTG-I1's HRV channel was used to capture the stunning animation of the eclipse path of totality over Europe. The satellite's imaging instruments were able to detect the subtle changes in brightness as the moon's shadow swept across the continent, providing a detailed map of the eclipse's progression. The data collected by MTG-I1 during this event will be invaluable for scientists and meteorologists studying solar eclipses. By analyzing the satellite's